How are men and women different physiologically? That appears to be a simple question. Most of us would immediately name the reproductive system and reproductive behaviors. Many may also recognize the differences in muscle mass and body fat. But in fact, we can find structural and functional differences in many, if not all, organ systems between men and women. These organ-level sex differences have significant impact on physiological function. Here we focus on the kidney. Even though the kidneys in males and females look similar, there are important structural and molecular differences that affect their functions. The kidney excretes waste, maintains salt and water balance, and regulates blood pressure. Each of our kidneys has about 1 million of these tiny tubes called nephrons to remove waste and extra fluid from the body. As blood flows through a nephron, almost all the water and sodium are reabsorbed through membrane transporters, channels, and pumps. The kidney essentially excretes in urine the amount of salt and water we consume. That works the same in men and women. Membrane transporters and channels are responsible for reabsorbing water and salt, and some of them are expressed at rather different levels in males and females. So even though the kidneys in men and women are reabsorbing similar amounts of salt and water, where along the nephron those processes happen may be different. For instance, females transport a smaller fraction of the filtered sodium and water along the proximal tubule, so that the downstream distal segment is responsible for more transport work. How does that affect kidney function and the rest of our body? Let's consider hypertension, the silent killer that affects about 1/3 of the world's population and half of the adults in the United States. Hypertension affects men and women differently. Premenopausal women are less likely to have hypertension than men of that age, although that female advantage disappears after menopause. That may be partially explained by the sex differences in kidney function, because the kidney has an important role in regulating our blood pressure. But what is puzzling is that even though women are more compliant with their medications, more men are successful in getting their blood pressure under control. Why is that? To understand this paradox, we conduct model simulations of the effect of a popular antihypertensive medication called the ACE inhibitor. The ACE inhibitor affects most nephron segments by changing the activities of some of the key transporters, with the goal of increasing sodium excretion and urine volume, and as a result lowering blood pressure. Because the expression pattern of these transporters is different between males and females, the effect of the ACE inhibitor should also be different. Indeed, our model predicts that the ACE inhibitor increases sodium and fluid excretion in both men and women, but the effect is stronger in men. That points to ACE inhibitors possibly being less effective in women. It has become increasingly clear that experimental and clinical results obtained in one sex cannot be extrapolated to both sexes without sufficient justification. A better understanding of the sex differences in renal physiology and pathophysiology is a necessary step toward more effective therapeutic treatments for men and women.